We learned in class the other day that the inverse of an exponential is a log. So just to review some of those topics on how to convert from exponential form to log form and from log form to exponential form. So we're just going to practice a little of that, and then what we're going to do is solve some what are called simple log equations. So before we begin solving simple log equations, we're just going to have to review going from one form to another. This is exponential form because it has an exponent, and this is log form because it has a log. So if we want to convert to log form, we just have to remember that the word log means exponent. So x is the exponent. X equals log. X is exponent. Also, x is the exponent of what? X is the exponent of 4. So the base is 4, which means the base of the log is 4. So the number on the bottom is the base, and the base of the exponential is the base of the log, which makes it pretty easy. Now the only thing that we have left is y. All right, so just to review here, remember that the word log means exponent. 4 is the exponent here, so x is the exponent of 4. The base of the exponent is 4, therefore the base of the log is also 4. And the only thing left is a y. In order to convert from log to exponential form, there's really two ways you can think about that. You can say y is the exponent of 6, which is x. Another way I like to think about this is to get rid of, just change the order of that and say log base 6 of x equals y. The reason I like it in this form is because then you could use a little mnemonic device that I like to call left, right, center. Left, 6, right, y, center equals x. You can only use left, right, center if it's in log equals form. If it's in x equals log form, for example, then you have to say x is exponent. X is exponent. But if it's in log equals form, you can say left, right, center. Okay, just an easy way to convert from log to exponential form and from exponential to log form. Just a little background information there. That's not the point today. The point today is to solve simple log equations. I'm going to use a pretty easy expression, an easy equation, 2 to the third power equals 8. We know that that's true. We know that 2 to the third power is equal to 8. What I'm going to do, I'm going to convert this to log form. And then we're going to identify the 3 parts of a simple log equation and see what we do depending on what's missing in these equations. So if I convert this to log form, 3 is the exponent. 3 equals log. 3 is the exponent of what? Well, 3 is the exponent of 2. So the base of the exponential is 2, which means the base of the log is also 2 of 8. So this is 2 to the third equals 8 written in log form. So if I change the order of this, I really just don't like 3 equals log, so I'm just going to switch the order here and say log base 2 of 8 equals 3. So now there's 3 parts here. Log base 2 of 8 equals 3. There's 3 parts here. There can be 3 possible missing equations. What would happen if we were missing the base? Log base x of 8 equals 3. Well, what would we do if we were missing the of part? Log base 2 of x equals 3. And finally, what if we were missing the equals portion? Log base 2 of 8 equals x. So now what we did here was to identify the 3 parts of the simple log equation, a simple log equation. We have the base, we have the of, and we have the equals. Depending on what's missing here, you can yield 3 different types of equations. So depending on the simple log equation, depending on where the variable is, that's going to change your approach. So the first step to solve the simple log equation is to convert it to exponential form. So I'm going to solve all 3 of these equations separately. These are 3 different equations here. So if we're missing the base portion, let's write this in exponential form. This is in log equals form, so we can use left, right, center. Or 3 is the exponent of x. Any way you think about it, this is red, x to the third equals 8. So now this goes back to a topic that we worked on a couple weeks ago, equations with negative and fractional exponents. The variable's in the base, so we have to isolate the base and raise each side to the reciprocal power. So I'm going to say x to the third to the 1/3 equals 8 to the 1/3. Fractional exponent, or red power over root. So that's just asking me to take the third root of 8, which is 2. So, convert it to exponential form and identify where's my variable. That will change your approach. So now let's convert this to exponential form. 3 is the exponent of 2, or left, right, center. 2 to the third equals x. Well, this one's easy to figure out. This is just asking you what the heck is 2 to the third power. That's 8. 8 equals x. And in the last case, let's convert this to exponential form. Left, right, center, or x is the exponent of 2. Either way, you get 2 to the x equals 8. Now the variable is in the exponent, as opposed to the variable being in the base. When the variable's in the base, reciprocal power. When the variable's in the exponent, set the bases equal somehow. So we have to manipulate 8 and express it with a base of 2. And if you have trouble with this, you can go back to exponential equations, which was about 2 weeks ago. So the common base is going to be 2, so we have to think to myself, 2 to what power is 8? 2 to the third. Now that the bases are the same, I can say the exponents have to be equal. So there's our approach. To solve a simple log equation, convert it to exponential form and determine where is my variable. Is my variable in the base? Raise each side to reciprocal power. Is my variable on the other side? Just evaluate some base and exponent. Or is my variable in the exponent? If so, set the bases equal. So depending on the part of the log equation that's missing, there's 3 different types of approaches, because there's 3 parts of a log equation: the base, the of, and the equals.